Hello everyone, and welcome to the second part of the budget RC drift build. As you might remember in the last video, I unboxed and assembled one of the most affordable rear-wheel drive drift kits on the market, the Sakura D4, as well as discussed my plans for building a solid yet inexpensive drift car. If you haven't yet seen the first part of this series, I will be sure to include a link in the description. By the end of that video, I had a complete rolling chassis ready to mount the electronics. As for the body, I chose an ABC Hobby Nissan 180SX. Although there are a lot of cheaper options for bodies out there, I really wanted a 180, plus the quality and scale appearance of ABC Hobby bodies is among the best out there. Today's video will probably be a bit on the shorter side, but the topic is very important, as I will be installing all the necessary electronics. Selecting the best components for your vehicle can be a bit of a challenge, especially when faced with a tight budget. We'll start with the ESC and motor. One thing that was important to me when choosing a motor was getting a brushless, censored motor. There are pros and cons to brushed, brushless, uncensored, and brushless, censored motors, but the biggest reason I went with a censored brushless motor was the smooth throttle response, especially at low throttle. I went with this Oniseki Hellblaze 60 amp brushless censored ESC with a 13.5 turn brushless censored motor I got as a combo from RC Mart. I've heard this motor and ESC are decent, and $63 seems pretty reasonable. I'm not sure what turn number is best for drifting, but I think 13.5 turns should be a good place to start. Both items were packaged well and included detailed instructions and specifications. After soldering the 3 motor wires from the ESC to the motor, I mounted it to the chassis. I'm not sure if this kit includes screws to mount the motor to the chassis, so I used 2 M3 by 6mm machine screws not included with this kit to secure the motor. I used a 21-tooth 48-pitch pinion gear, which seems to be about the smallest size that can be used with this motor mount. I want to keep the speed of the vehicle relatively slow in the beginning, so that's why I chose a smaller pinion. I like that there are no obstructions around the pinion gear or the motor mount screw holes I'm using, so changing the pinion and adjusting the position of the motor is easy. For the steering servo, I'm using a Turnigy D-Spec DRFT 303 drift car steering servo. I've used these servos on other builds, and they're pretty decent for the price, but if you can afford to get something better, you would definitely be better off doing so. This one I've had sitting on a shelf for a while, so I thought I'd put it to use on this build, but I'll probably upgrade it in the not too distant future. Before mounting the servo to the chassis, I needed to mount the steering arm and servo linkage, both being very simple to assemble. And here's a look at the installed steering servo. Here I'm assembling the battery holder. I decided to mount the battery in the rear to free up space in the center of the chassis. For a battery, I'm using a Genzace 4600 mAh 7.4 volt hard case LiPo. I've had a lot of success with Genzace batteries in the past, and I hear a lot of good things about them from other hobbyists. They're also a good value. I picked this one up for a little under $40. The last major electronic component to mount to the chassis is the receiver. I'm using a Radiolink R4EH-G. It's small, light, and cheap, plus it has a built-in gyro. I'm not sure how well it will work for drifting, but I'm curious to find out. I'll be pairing this with a Radiolink RC4G transmitter. I already owned this receiver and transmitter, and using components you already have is one way to help make a build more budget-friendly, and you can always upgrade later on when you have more money. I don't want to mount the receiver in the middle of the chassis because I'm planning on adding an interior. I thought I might have to 3D print a custom mount to attach it somewhere on the front, but it turns out it fits perfectly in the spot between the front control arms. Hopefully, choosing the position of components based solely on making room for an interior doesn't have too much, if any, negative impact on the handling or driftability of the vehicle. I might move everything to the center at some point just to get a feel of how that might change the way the vehicle drives and drifts. I want a car that looks scale as a snake, but I also don't want to compromise too much on how well it drifts. I cut the body out and sanded around the edge. I didn't film this process, but it's pretty simple. All I did was go around the edge of the body with a sharp X-Acto knife, first pass being light and then cutting deeper with each following pass until the excess material around the bottom can easily be separated. And then I use a rotary tool with a fine sanding drum at a low speed to sand away any imperfections. Then I go around the entire edge with sandpaper and sand the edge by hand until the wheel arches are smooth. I'm going to be making my own body mounts since the stock position in the rear is directly under the rear window, and the front mount would attach to the underside of the hood, and I don't like putting body mounts there because it would not allow me to make the hood be able to open. I would have liked to test out the electronics in this video, but I'm out of Dean's connectors so I don't have any to solder to the ESC, but more are on the way, so I'll definitely have this thing up and running in the next video. But that is all for this video. Thank you for watching, and if you enjoyed it, I would appreciate it if you subscribe to my channel and leave a like as well as a comment. Also, for additional content and more frequent updates, be sure to follow me at the social media links below. And as always, if you have any questions, feel free to leave it in the comment section below, and I will do my best to answer it. Thanks again, and I'll see you next time.